Video we'll see one format which is data sufficiency, which is extensively used in GMAT quant section, and we'll see some tricks and traps of this. So data sufficiency is one of the formats in GMAT quant. There are two types of question formats here. One is problem solving, wherein there is a question and there will be 5 answer choices. Okay. Out of them, exactly one would be correct. Okay, it's always one correct, not more than one correct are possible. So we just need to pick or mark that correct one. Okay, so it's a simple multiple choice question kind of format. Okay, everybody must have seen this kind of formats in some exam. So that's not really a problem. Data sufficiency is another kind of format that is used very extensively in GMAT quant section. So let's see what is this format. Let's say the question is, there will be some question, what is x? Okay, we need to find value of x, let's say. So that's plain simple question, what is x? Okay, there is nothing given about x. Then there will be two statements, statement 1 and statement 2. Okay, now the question's format is data sufficiency. We need to figure out which statement is sufficient to answer the question. Okay, that's what is required, right? We are not marking the answer value anywhere. We are not marking the value of x anywhere. We just need to know which statement or statements are like some sort of information about x. So which information would be sufficient to answer the question, to get the value of x? That's what we need. Okay. Let's see the answer choices. So every DS question will have same answer choices. Okay. Answer choices will remain same always. Okay. Pause this video for a minute. Just go through all the statements carefully. Okay. Now in the next slide, we'll try to understand what they mean exactly. Statement A means, answer choice A means statement 1 alone is enough. Okay, this word alone is important. Okay, statement 1 alone is enough, 2 alone is not enough. That's what answer choice A is. Okay, so as we know, there will be two statements, statement 1, statement 2. What we'll do is we'll see what information is given in statement 1 and what answer we can get. Okay, question was what is value of x? So what values of x we can calculate from here. Then we'll see, let's say we got some value from there. Then we'll go to statement 2, and when we go to statement 2, we need to forget about the statement 1. That's the meaning of alone. Okay, when we look at one statement, we don't know anything what is given in the second statement. We can't use anything that given in the other statement. That's the meaning of alone. Okay, so let's say 1 alone is enough, 2 alone is not enough. That is answer choice A. B means 1 alone is not enough, 2 alone is enough. C means neither is sufficient alone. That means we checked with first statement, that was not sufficient. We checked with statement 2 alone, that is not sufficient. We need both. That means we'll have to use both the statements. Okay, we'll have to use the information given in both the statements. We need to club that information, and that will be sufficient to answer the question. D means 1 is also sufficient, 2 is also sufficient. E means 1 individually, 2 individually were not sufficient. Even if we combine, that is not sufficient. Okay, so if combination is not enough, the answer choice is E in that case. Okay, let's see some examples, because then only we will be able to imbibe these answer choices well. Let's say question is what is x? Okay, statement 1, says x square is equal to 16, let's say. Now every statement is like some information about x. Okay, our job is to use this information, okay, and find the answer to the question, okay, which is finding the value of x from here. So in what kind of questions we need to find a numerical value, like 2, 3, 4, so that sort of values. So now for x square to be 16, x could be 4, x could be negative 4, both. Okay, both values of x would satisfy. Okay, so we can get both answers from this statement. So if a statement gives me more than one possible answer, okay, more than one values are possible, that is not sufficient. Okay, so if x square is 16, x could be 4 also, x could be negative 4 also, both are equally good for me. So more than one answer is possible, so that is not sufficient. For example, if I ask you what is the length of the room, let's say any room that you are sitting in, what is the length of the room? So one person says 10 feet, another person says 12 feet. I did not get my answer. Okay, so if I am getting more than one possible answer, that is not sufficient. Let's say second statement, statement 2 says x cube is equal to 64. Okay, now when I look at the second statement, I can't use anything that is given in the first statement. Okay, so what possible values of x are there? Only one possible value. Okay, so that is sufficient. Okay, the statement is not sufficient only if more than one answer is possible. So only one possible answer here, only one value of x will satisfy this statement, that is sufficient. Okay, so first was not sufficient alone, second alone is sufficient, answer here would be B. Okay, one alone is not sufficient, two is sufficient, that is. Now let me change the second statement. Statement 2 says x is positive, x is greater than 0. Now what values of x will satisfy it? Multiple values. Okay, if x is supposed to be more than 0, it can take so many different values, so not sufficient. Now 1 is also not sufficient, 2 is also not sufficient in this case. Now we go for combination. Combination means I'll use both the informations together, or I'll take only those values of x that will satisfy. So I'll take only those values of x that will satisfy both the conditions, both the statements. Okay. Now if you see, 4 satisfies both. Okay, 4 will satisfy this also, 4 will satisfy this also. So 4 is a possible value. Negative 4 will satisfy first, but it will not satisfy the second one. Okay, so negative 4 as a value does not satisfy both the statements. Okay, and if you see, no other value will satisfy both the statements other than that, because first is satisfied only with these two values. So I don't need to check for other values. After combination, it's only one possible answer. Only one possible value will satisfy both. So that is sufficient, and C is your answer in this case. Okay. Let me change the sixth statement second again. Let's say it says x is greater than negative 5. Okay. Again, not sufficient because again -4, -3, -2, 1, 2, 3, all these values will satisfy the statement. So we can have multiple values of x possible, not sufficient. Again, I need to combine the two. 4 satisfy both statements, negative 4 also satisfies both statements. Okay, it satisfies first, and x should be greater than negative 5, so negative 4 is greater than negative 5. So even after combination, we get more than one answer, more than one possible answer. Even combination is not sufficient, and when combination becomes not sufficient, is your answer straightforward. You don't have to do anything. So that's what we do in what kind of questions. We need to find a numerical value, and statement is sufficient if we get only one answer. Now there could be is kind of question also. Is X positive? Okay. So if I ask you, is it a Sunday, Monday? So I'm expecting a yes or no kind of answer from. So in this case also we'll try to figure out yes and no cases. That's it. For example, first statement says X is greater than -3, let's say. Okay. So this is 0, this is -3, this is greater than -3. Okay. So now X could be negative also, X could be positive also. Okay. Like X could be -2 also, X could be 2 also. So 2 would be a yes answer. We are asking is X positive? X could be 2, yes positive. X could be -2 also. That's a no answer. Yeah, X is not positive. Okay. So if we get both yes and no cases, that is not sufficient. Okay. If a statement gives me both kind of answers, that is not sufficient. Let's say second statement is X is less than 3. Again, this is 0, this is 3. It says X is less than 3. So again, it could be positive also, it could be negative also, it could be a yes answer also, it could be a no answer. So not sufficient. We are getting both kind of answers. Now first is not sufficient, second is not sufficient. We combine the two. Okay, combine the two means X should be greater than -3 but less than 3. So that means this is the common area. Okay, that will satisfy both the statements. So X could be anywhere on this region, this common region. Again, it could be positive also, negative also, it could be yes answer, it could be no answer. Even combination is not sufficient, E would be the answer in that case. Okay. Now let's say I have one statement which says X is greater than 2. Okay. So on the number line, this is 2, this is 0. So more than 2 could be 3, 4, 5. Now multiple values are possible for X, but we are not concerned with multiple values, we are concerned with yes and no cases, and here we'll get only yes case. Okay. If X is greater than 2, X can only be positive. Okay. So this is sufficient because we cannot get a no case. Okay. We cannot get a negative or 0 case. So this becomes sufficient. Same way, if a statement says X is less than -2, this is 0, this is -2. It says X is less than -2, so -3, -4, -5. Again, multiple values are possible, but what are we looking at is yes and no cases. So every case here would be a no case. Okay, -3 is a negative case. I mean, question is X positive? X could be -3, no, X is not positive. X could be -4, no, it's not positive. X could be -5, no, it's not positive. So every time we'll get a no case, so this is confirmed no. That is also sufficient. Okay, confirmed yes or confirmed no, both are sufficient for me. Okay, remember, it will not be sufficient only if we get both yes and no cases. If we get only one case, that is sufficient. For example, on a Monday, if somebody asks you, is it a Tuesday? Okay, you'll say no, and that's a confirmed answer. That's not a problem. Okay, so confirmed no is also sufficient. Let's take care of this thing. Let's take one more example. Is X greater than Y? Let's say that is the question. First statement says X minus Y is greater than 2. Second statement says 7X is equal to 5Y. Okay. Now pause the video, take a minute or two and try to solve the question. Try to find A, B, C, D answer. Try to see which statement would be sufficient. Now let's see, how do we see it? Okay, Y is subtracted from X. Okay, and the result is greater than 2. Greater than 2 would be a positive value always. So it's always bigger number minus smaller number for the result to be positive. It will always be it like 6 minus 2, so 6 is bigger. Be it minus 2 minus minus 6 is also greater than 2. I mean, it's equal to 4, so greater than 2. Now, minus 2 is bigger than minus 6. Okay. So, be the numbers positive or negative, there will always be a bigger number minus smaller number to get a positive result. So, this is sufficient. Okay. We will get only yes case, we will always get x is more than y. So, first is sufficient. Now, first is sufficient, I can't mark any option as of now, I need to evaluate second statement also. Second statement says 7x is equal to 5y, so I can say x upon y is equal to 5 by 7. Okay. Now, x is equal to 5, y is equal to 7 will satisfy it, and this is x smaller here, so it's a no case. Okay. Question is x bigger? It says no, it's smaller. Now, most of you, or a lot of you, if not most, would have marked it sufficient, ki x is smaller. But is it the only possible case? Now, see, if x is equal to negative 5, y is equal to negative 7. This will also satisfy, x by y is equal to 5 by 7. But in this case, x is bigger than y. Okay. X is negative 5, y is negative 7, x is bigger. This is a yes case. Okay. So, we got a no case, we got a yes case, that also this becomes not sufficient. So, first sufficient, second not sufficient, A would be your answer. Okay. So, mostly what happens is, in DS questions, we take positive integers, okay. Instinctively we take positive integers and we forget about number could be negative also, number could be 0 also, number could be a fraction also. Okay. Okay. Instinctively we think of numbers 1, 2, 3, 4, 5 and so forth, but the numbers could be minus 1, minus 2 also, negative also. Till the time the question doesn't say x is positive, that means negative cases can also exist. X can be 0 also, x can be a fraction also, like 1 by 2, 1 by 5. Okay. If the question doesn't say x has to be an integer, then x can be a fraction. Okay. So, mostly these cases give me different cases. For example, we took negatives here, we got a different case. We got a no case here, and when we took negative values, we got a different case, the yes case. Okay. So, mostly these are the very small fundamental mistakes that most of the people make initially with DS. So, we need to be a little conscious about these things. So, if the question says x is a number, that means it could be positive, negative, 0, it could be 1, 2, 3, it could be an integer also, it could be 0.5, it could be a fraction also. So, we must keep that thing in mind, and we must check whether a different set of values, like be it integer or fraction values, can give me a different case or not. Okay. We must evaluate. Okay. Maybe they don't give a different case, but we need to evaluate. Okay. So, that's what we need to take care of in DS. Okay. So, these are the